Hello, my name is Christian Lang, and as you've seen in the introduction, this is a tutorial video or more kind of a walkthrough for my Aurora Borealis asset, also known as Northern Lights. A Aurora is a very complex thing to create in CG. There are many pretty dynamic physics involved, and as most things in CG, we want to have a good balance between complexity and control. So the real challenge here was to make this effect art directable. The biggest problem I encountered is that it had to be volume based. When I started, I first had the idea to do this with kind of a animated band with a texture on it, but you'll see in a moment why that won't work at all. So I came up with an approach that should work in 90% of all scenarios, because the end result is a volume, but it's constructed gradually based on a very simple geometry. Also, I tried to keep the basic controls simple, but leave some options to expand them later on for more control. There's a simplified version of a Aurora that I call a blueprint. And while the full version, the volumetric one, takes a while to render, this will run almost in real time and give you a good impression of the dynamics and fast interaction for control. First of all, a tiny overview. Let me get rid of this rendering. I start with a base curve, and there's a couple of places where you can interact with that, where you can plug in your own curve and create a basic animation by hand. But the idea is to have a couple of noises and different frequencies run over that curve to modify it. And this is not just one noise, this is a noise that distorts the UVs, that's a sinus curve. I'll show that in a moment. And then there's a second wave going over that creates kind of the finer frequencies and makes it a little bit more dynamic. But the idea is that you'll go through it step by step. You start with the bigger movements, and you eventually align the bigger movements of various curves, and it's a prospect that I want to change when I expand that thing, that you can have various curves aligned towards each other and have some in the middle, and then you kind of change the movement of 2 or 3 curves in your scene, but a lot of the finer details will align to that. So I made this approach with the prospect of getting there, but I don't have time to fully implement that right now, so I'll do that later. And then we come to the blueprint. What I do here, and let me just show you that this is a grid, basically. Deleted all the unnecessary points. So when I started this project, initially I also used a base curve, and I used a polywire to expand that base curve into a band, which looked kind of like this. And then I pre-calculated some values to create kind of an offset for the subtle movements that wouldn't result in this banding, but be more like a shift perpendicular to the curve. There are 2 problems, and I tried a couple of solutions, and none of them were satisfying. First, you have those huge intersections, and because of the way I calculated the noise and all the various parameters, there was no way to kind of soften those areas out. So in the end, I discarded this whole approach and went for the grid-based solution, which offers me a lot of ways to solve those problems, and also this looked rather nasty when I transferred the attributes to the volumes, because sometimes this would end up bigger than the Nyquist ratio, and there would be zeroed out areas in between, so this didn't work. And I had a couple of solutions to interpolate from that, but because the resolution would end up really high, that was pretty costly, and I had render times 5 or 8 times the size that I have now. Okay, so let's go back to the grid-based approach. Then I decided to kind of write my own custom scripts in Wax and transfer the attributes from the base curve. And it's not just the base curve geometry. There's a lot of attributes written into the vertices, different gradients, the width, the brightness, and so on. And all those get transferred to that grid through custom scripts. And I also use various processings like smoothing things out. And then I get this blueprint. I can modify quite a lot of parameters on this blueprint. I can shift the noises through the blueprint. I can change frequencies. I can change intensities. And from that point, I extrude into first a geometry, but with a lot of intersections. I'll show you what that looks like. Okay, so here's my extruded geometry, and as you see, it's pretty much a three-dimensional grid already, and that grid gets fed into a volume VDB, and as you notice here, well, this is on the outside. It's a little bit darker already, but I use various fade-off gradients that you can also control here. So let me. So this is the place where you can check the fade-off. There's also some distortions that will push the height of the Aurora. Let's see what that asset can do. First of all, as you've seen, I can switch between various views, and I included this little render button because when I check things and I modify parameters on the blueprint, for some reason every now and then it gets updated, even so I put the renderer on pause, and that's why I switch it off for now. Global feature size. This is like global size parameters. So the base curve stays the same, but I can change, all the frequencies are kind of tied to this parameter. So if I change this, then everything gets smaller. And this is to adapt to your scene size. Main amp, of course, is the overall brightness. All those parameters here are ramped. So let me switch that off for a second. Width, length, and so I start with those deformations, and I always have like a size multiplier, so I can scale things up or make those waves smaller. I try to have only like 3 or 4 bands within one single curve. It looks more natural. This is the amplitude. What happens under the hood is, let me check that. So here are a couple of tools, primary distortions, that should be it. So basically what I do is I create a sinus wave that can travel along my curve. And I have a couple of parameters to set this up, to kind of normalize it to the curve length, set frequencies of the sinus curve, etc. So what I do is, to make it look a little bit more fractal and interesting, I distort the V parameter along the curve with a fractal noise, and that distortion gives it a much more naturalistic look, but still stays within that wavy character that I want to achieve. And so I have a noise that goes along the curve and can travel along the curve also, and I have a noise that's kind of a pass-through noise. It's a little bit like taking a laser pointer and moving it to some smoke or fog. The noise will change on every point of the curve, but because it's anti-aliased, it will change slowly, and that will give you more like a waving look. And then in the end I have a couple of things to process that, the amplitude and such. And that's basically everything I need, and I use that in 2 layers. So the first one is just that sinus wave with the noise, and then there's another one on top of that. I'll show that in a second. Let's see what that looks like. So first let me turn off any editing on that curve. Yeah, and that's my basic wave. Let's make it a bit shorter. And there's the offset, here's the speed, so it runs very slowly. And then here's the distortion. I can make this a bit rougher and increase the frequency. So you see where this is heading. This needs to be in balance, of course. This is pass-through motion, this is parametric motion. Yeah, and that's basically it. I do that 2 times for the smaller and the bigger movements. Second deformation is kind of the same, just smaller frequencies. So here's a scale multiplier in relation to the first one. So they're bound together. And everything else is pretty much the same. So if I offset this, you can see it travels along the curve. If I offset this one, it's kind of changing on every point. So let's dive back in, see what we have here, what else we have here. This creates my curve. This is a edit that you can dive in even when the asset is locked. I resample here. I create a couple of attributes. This is my gradient. I generate UVs, take some measurements and calculations that help me, what comes later. Polyframe, I fix that. And then there's my distortions. And let's see. I again fixed it. I could put that all in one place, but because I had the approach first where I would generate that bigger wave, and then to avoid intersections with the smaller ones, I would create a offset attribute and then offset those curves along the first wave to avoid those intersections. Here's the second distortion. There's the option to carve, so if you don't want to render like the whole section, you can carve out a little bit for prototyping, for seeing what it looks like without having to render the whole line, and that saves a lot of time. It's also on the asset. I promote a couple of attributes. This is like UV calculation, because I recalculate the UVs after the length has changed due to the distortions. I take the displays that I talked about and apply it. I always have, those are my pickup points, so this is where I feed into the previews. Then I process the grid, so I have a grid that auto aligns to the size of the curve, and the resolution is linked to the voxel size of the volume. I have attribute wrangle. It's not very long. What it basically does is I use a PC. Maybe I showed it in Photoshop and make a little scribble. Yeah, let's do it that way. So what I do is I set my search width, search radius to 0, and I search based on the point radius. So my problem in general with my approach is when I have something like this, and I would only search like for the closest point, and try to fetch the attributes from that point, which is what I'm doing. And when I have a width that's pretty uniform, so let's say my basis is this broad, and then it's pretty clear like what side I'm taking the attributes from. Like when I'm here, I will take those. When I'm here, I will take those. And this is basically like the calculation that I do. I take the grid point and I say, okay, this point is the closest. So I take my V attribute and then I take the distance. And based on that, I do the calculations, because those feed into my UVs and those UVs feed into my fractals. But if I have a variance in that width, so I start very narrow and then I go broader, or let's erase this. So I start very narrow and then I suddenly get pretty broad. I want to take that into account, and I can change this radius. I can say like it has to be very small in the beginning, and then later it gets pretty. Sorry, I don't have a tablet monitor right now, so this is not a proper circle. And I can do that with the PC fine, and that's why I'm using this method. And then I get an array of all the points that are nearby, and I run through that array and I try to find the point that's actually the closest, and use that as a parent point and fetch basically all the necessary attributes from that parent point. With the distance attributes and with the location of the parent point, which is UV based, so I get a value between 0 and 1. I smooth that out later. And let's see what that looks like. So yeah, this is like the calculations that I do. I fetch the energy, the length, curve position, curve UV, the blur attribute, which I use later on the volume, and then I basically blur those attributes on the grid. And I can show you one image. Yeah, this is basically just a gradient to see, okay, how are the points attached to the various parent points. Here's some tests that are done as a work in progress. First one, I put a high frequency noise on the curve and transferred that to the grid, and you can see where there's break at different positions from one curve position, one parent curve position to the other. Then here is the unblended, unsmoothed version. You've seen like the smooth one earlier. And then we have like another test with a little bit smoother noise. This is still unsmoothed. So curve position is not blended properly. That's why there's still some harsh breaks, but it's just a proof of concept that this transfer works and gives you an idea of how I approach the whole thing. Next, I create my luminance. There's a couple of options for variation, but I won't dive too much into that. And this is what I call like the blueprint. And then I extrude that, as I shown before. There's various calculations here too, but maybe let's just dive into this one. So I have some motions and frequencies based on the length. I have the same pass-through motions, and basically what I do is I collect all the various frequencies, time-based, position-based, feed into one noise, add some calculations and ramps that are optional. Then this part down here, what it basically does is it creates a couple of nodes and calculations so you can change like the intensity spread. So you can have this peak very much in the middle, I showed it in a moment, or you can have like a smoother gradient to the sides. That was also pretty tricky to find a good solution to have that controllable to ramps. If you want to know some details how I done that, just write me. If there's interest, I'll make some more detailed videos. This is just the overview. And then I go extrude that. I basically, how I do it, I extrude the whole attributes from like the base mesh, and then I multiply that, so I lower the values based on a height gradient. Pretty straightforward. The split base color was because there's some nuances in Auroras that are not yet included, and I would like to have that in future versions. So I already set up like various attributes to have two different pathways, one for the main basis, and then there's those little sparkles and streaks that occur, and I can set them up later on. And this is all like VDB processing. So I included the option to have the Aurora blur with height and also blur with the length along the curve. And this is because usually, like when the energy comes in, when like the solar rays come into the atmosphere, they tend to get scattered, and also, and that's also something for future versions. The red parts get more scattered than the blue and the green. The reason is that gradient, please update. Oh yes, I forgot to switch that back on. So you don't see the red right now because it's not really strong, but first there's the red parts in the higher atmosphere, and what happens in physically is like a ray hits a atom and an electron jumps out and jumps back in, and the higher parts of the atmosphere, this jumping back in of the electron is what creates the light, and in that case the red light, and it takes about a minute between the hit and the jumping back in until the light is spread out, and within that minute there's a lot of motion because the atom gets a lot of energy and it gets a kind of an impulse to travel. And so first there's a delay between this part and the lower part, which happens within a second, and also with the traveling distance there's certain blur that occurs. So what I want to do later when I go on with this project is to have a time delay between the red parts and the green parts. But since I want to build in a couple of other things, I consider doing a little bit different approach in the end. Okay, what else? Yeah, there's the blur. Well, that's basically it. That's what I done. I wanted to explain why I don't use like this band approach, and the reason is pretty simple. If you look straight in this direction and the curve changes, so if you have a perpendicular view, then you get very sharp edges and corners, and you could solve that in post, but once you have a situation where you look from here above, or you have different curves intersecting, it gets pretty complicated and messy very fast. And it's one of the main reasons why I wanted to have that volumetric approach, so you kind of have that softness. You can make it very broad from the basis, and you can have various curves intertwined. Yeah, and then as I said, like the next step gonna be you have one curve here, and then you basically create automatic curves in between that have their own subtle fine movement but are kind of connected in the overall motion, and that will help create more defined layers. I mean, right now I have this banding approach, and of course it doesn't look that good right now because I deleted all my parameters. But let's say here you can create various bands, 1 or 2 or 3. You can have the noise set up, so there's a lot of things happening in between. And if you play around with it for a while, you get pretty good results. That's about the introduction. Okay, so let's get back to the asset controls themselves. We already had those 2 parameters. With this can be ramped. Let me switch that off. So this is just how broad the Aurora is. And as you can see, the broader I make it, the darker it gets, kind of. That is the link to the brightness with the width. You can switch it on or off here. We've seen that in the node graph. I can ramp this along the curve length. Nothing too fancy about that. And it takes a bit to get kind of a feel where that's necessary and where not. Also, you can animate that if you like. Side shift, I have to use this parameter a bit stronger to actually show that. Let me just... So, this peak fall off will create either a very sharp curve or smooth things out. And of course you can also ramp this. And what the side shift does, and I thought about doing an attribute, doing an approach that gives you more like a control on certain points in the curve, but I found that this works much better, even though you don't have that fine of a fall off control, but you can actually go and accentuate parts of the curve. Let's say okay, I want to have some of that background noise here still in, but mainly I want to focus on this band here, and then use side shift and kind of move that around, let's say to the rear parts here, and yeah, just use that to shape things a little bit. This parameter gives a control over basically how much noise there is parallel to the curve, and I wouldn't put this too high, but of course you can. And with the ramp you can use this to create smoother transition in some areas. Let's see where we are right now. Length. So this is luminance along the curve, and very easy, straightforward, no magic here. And this is the noise intensity, and let's turn this off so we see what it does. So at 0 we don't have any noise at all, and all we got is like the luminance ramp. And then once we introduce noise, we get those darker areas, and around 5 it starts to clip. So this would be like full noise. Some areas have no brightness at all, and then you get like those blank areas, and it turns more and more into islands that actually have brightness and the rest is dark. I found this pretty practical because you don't have two separate values for clipping and for noise, and then of course you have the parameter, and you can go in here and dial things up and forth a bit. Because this is linear in color settings, it might turn out differently when you render it. You just gotta get a feel for it. Pass-through speed, the same thing as before. So this offset will actually pass a noise like you have a slice going through a nebula and you move that slice up or down. And the along speed is the thing we had the whole time, so you just move it along the curve. And when you find the right balance between those two, it actually looks pretty good. Yeah, that's it for the tool. That's the overview. Oh yeah, extrusion. Forgot about that. So, preview. Yeah. So first we have a noise parameter for the height, and it takes a bit to calculate. Yeah, no, it's actually pretty fast. Good. So we have this parameter for the height, and we have a frequency for the height noise, and then there's color gradient. So I have like this energy parameter that just says like how much energy is going into those areas, and then I use that to create my green, blue, red gradients. This is deprecated, you can ignore it, and then I can just shift it around. And as I mentioned earlier, like I want to take the red gradient out of the whole thing and create a time shift, but I still have to find a solution how to feed that into like the base mesh and then transfer it to the volume without doing too many recalculations. And once I have like a really final version, and I don't find time for that right now, I'll probably do another update video. Then there's a volume runner, there's a voxel size, there's like a couple of switches for blur, so like there's an overall blur, there's a blur that goes with the height, so you have like lower areas or higher areas that are more blurred. Yeah, that's about it. So I live in Munich. I'm currently searching for a job in computer graphics, mainly as a TD. I have 12 years experience. I have a diploma from the German Film School in Berlin from 2006. So I got quite some work experience. Work in Maya, in Houdini, also 3D Studio Max. I did work as a 3D generalist. So if you have any jobs where you think like I would be a good expansion for your team, just write me a mail or a message, and that's it for today. Send me your feedbacks if you would like to know more about this asset or my approach. If you like to see further videos, I have a couple of assets at work right now. One for burning like a whole city with like how you say that in English, chimney effect, and various other things, and I'll probably have them finished within the next few weeks. So there'll be more walkthroughs, and eventually also like a step-by-step tutorial. Bye. So what I would do in future versions, first, as I said, create kind of a time offset for the red parts of the Aurora. Then create a system where you basically plug in 2 or 3 master curves, and then create in between curves where you can have a very defined art direction. And the third thing is, and that's the idea that gets a bit more complicated, and I hope I have some time to get into that. My idea is that in the end you just draw a curve, and there's a thing called Python states that came up lately, I think in Houdini 16.5, I'm still hoping, still waiting for Jeff Wagner to maybe do a bit more extensive tutorial on that. He talked about that when he was down here in Munich, shortly before the FMX. And what Python today does is you can actually interact with the viewport directly with Python tools, create your own custom scripts where, in this case, I would like to draw a curve. Then I use a method called fast Fourier transformation to reverse engineer that curve into sinus waves. So you draw a curve and then basically reproduce that curve with a couple of sinus waves of different amplitudes and different frequencies. And then you can shift those frequencies. So you will have a changing wave built on top of a wave that you draw on your own and not some random thing. And then you can really like fully art direct and just paint. I want to have some Aurora here and I want to have some band over there. You draw that, you tell it how fast it should shift those frequencies, those sinus waves based on their size. And then you have like a completely dynamic system where you can have an on-point interaction and definition. But I'm not that much of a mathematician to fully include that, so I'm still searching for some ready to use Python scripts. And hopefully I'll manage and then I'll send you an update on that. But if you pick up on what I've shown you so far and kind of go a similar approach, I'll be happy to hear from you. And maybe you better in implementing FFTs than I am. By the way, FFT is just like what you use to, and what you end up is a Fourier series, and then you use that to create your sinus frequencies. A couple of things about me. I studied at German Film School in Berlin. I'm a diploma digital artist with a focus on visual effects and natural phenomena. I've been working mostly as a generalist since 2006, but would like to focus more on the TD side of things. I live in Munich right now. I'm open for job offers. So if you're from Wise Effects or Trickster, I'll make sure you get my portfolio once I'm done with it. But I'm open for jobs by now. If you want to meet up, talk about some projects, exchange some creative input, I'm always happy to do that. I think Munich is a pretty good place to be in the industry right now. There's a lot of companies opening up. You'll probably see me at the next Houdini user group meeting. I have a couple of other assets and that I'm working on right now. Post them during the next few weeks. And if you liked any of the stuff I've shown, would like to know some more details, please give me feedback. I also have an Instagram account with no CG on it yet, but that'll change. One last thing. I've started working on this asset for a small advertising project. I worked with Kevin Muller from Visual Vitamin. And if you have any projects in advertising or 360 degrees video, make sure you give him a call. He's one of the most focused and reliable producers I met so far in the industry. That's it for today. Bye-bye.